Okay, good afternoon, students. Today we are going to discuss the new topics under the chapter solid states. There are certain new terms that are very useful for us and important for us. One is there is space lattice. Space lattice. Space lattice. So here in a space lattice there is three-dimensional arrangement. There is three-dimensional three-dimensional arrangement. Three-dimensional arrangement of identical points. Three-dimensional arrangements of identical points. Three-dimensional arrangement of identical points. Points means atoms, ions, or molecule, which represent which represent which, which represents how the constituent particles are arranged. How the constituent particles how the constituent particles how the constituent particles are arranged in crystal. How the constituent particles are arranged in crystals. Constituent particles means atoms, molecules, or ions. Three-dimensional arrangement of identical points. Three-dimensional arrangements of identical points. Identical points in the space. Three-dimensional arrangement of identical points in the space. Space lattice can be defined as three-dimensional arrangement of identical points. Identical points means atoms, ions, or molecules in the space, which represents how the constituent particles are arranged in the crystals. Suppose this one is the lattice structure. So the constituent particles are arranged where the constituent particles are arranged in the space. Constituent particles are arranged three-dimensional arrangement of identical points in the space. Three-dimensional arrangement of identical points in the space. These are atoms, molecules, or ions. How they are arranged in the crystal lattice, that is known as space lattice. That is known as space lattice. Three-dimensional arrangement of identical points that are arranged in the space, which represent how the constituent particles are arranged in the crystals. This is known as space lattice. Now we will go through the unit cell. Unit cell. The smallest portion. Unit cell is the smallest portion Unit cell is the smallest portion of space lattice of space lattice. Smallest portion of space lattice which when repeated in different directions, which when repeated when repeated in different direction, which when repeated in different direction, which when repeated in different directions generates the space lattice, generates the space lattice, generates the space lattice. So unit cell under the space lattice is a smallest portion of space lattice. Unit cell in the space lattice, there are so many unit cells, and these unit cells are the smallest portion of space lattice which when repeated in different direction. As I have told just before that suppose this is space lattice and crystals in space lattice of the crystals, and atoms are arranged in different points, different identical points. Atoms are arranged here. So the smallest portion of this space lattice, smallest portion of this space lattice is known as unit cell. The smallest portion of this space lattice is known as unit cell. So where are all these are the unit cells in the space lattice, which when repeated, this is repeated in this direction, repeated in this direction, repeated in this direction, repeated in this direction, and in this direction, in different direction. When the same unit cell is repeated, they give rise to the shape of space lattice of the crystals. They give rise to the shape of space lattice of the crystals, and these are the points. These are the points where the crystals are, where the atoms are arranged in the space lattice. So this one is the unit cell, this one is the unit cell, and these are the different unit cells giving rise to the form of space lattice. So space lattice is the smallest portion of space lattice, the smallest portion of space lattice, which when repeated in different direction, repeated in different direction, they give rise to the shape of unit cell. They give rise to the shape of space lattice. Repeated in different direction, they give rise to the shape of unit cell. They give rise to the shape of space lattice. So this whole is a space lattice of the crystal, and these different are the unit cells. These unit cells repeated in different direction and give rise to the shape of space lattice. So there are there are 6 parameters. Unit cell has 6 parameters. Unit cell has 6 parameters. 6 parameters means there are 3 axial angles, and 3 axial lengths, 3 axial angles and 3 axial lengths, 3 axial lengths. There are 6 parameters of the unit cell. In 6 parameters, there are 3 axial units and 3 axial lengths. Suppose This one is the unit cell. Suppose this one is the unit cell. This one is the unit cell. Suppose this one is the unit cell in three-dimensional structures. This one is the unit cell in three-dimensional structures. So one is the angle is this, another one is the angle is this, and another one is angle is this. And we can represent these angles alpha, beta, and gamma. Three axial angles are alpha, beta, and gamma. These are three axial angles are here, and we can write A, B, and C. A, B, and C. These are axial lengths. These are axial lengths, axial angles, and axial lengths. And these are the points. These are the points where the molecules, atoms, molecules, are ions are arranged. Atoms, molecules, are ions are arranged. Here in this case, these are the four corners. These are the four corners where there are the four corners of the unit cell of space lattice where the atoms, molecules, or ions are arranged. And there are six parameters. There are six parameters, three axial angles and three axial lengths of the unit cell. There are different kinds of unit cells. There are different kinds of unit cells. Number one, simple cubic unit cell, body centered cubic unit cell, face centered cubic unit cell, and edge centered cubic unit cell, edge centered cubic unit cell. There are the four types of unit cells you can see in different types of crystals, in different types of crystals, in different types of crystals or of space lattice, in different types of space lattice of crystals. You can see different unit cells, and in unit cells there are six parameters alpha, beta, and gamma, and A, B, and C are axial lengths, and these unit cells are of four kinds: simple cubic, body centered, face centered, and edge centered. And there is the questions that we should know that how many atoms are arranged, how many